Hello, in this video, let us find together the value of x. So when we have it to be solution, now from here we are given x times root x equals 1. Then from here, let us recall that to eliminate this root, we can square both sides. So we have here to be x multiplied by root x square equals 1 square. Then when you have AB squared equals as a squared times b squared. So from here we have this to be x squared times root x squared equals 1. 1 squared is 1. So from here this we cancel out this. So we have x squared times x equals 1. Now, from here, let us recall that when you have a to the power of n times a to the power of n from the law of indices equals as a to the power of m plus n. So applying it here, we have x to the power of 2 plus 1 equals 1. Then from here, so we have this to be x to the power of 3 equals 1. Now, we have to be very careful here. Don't let us equate so we can have all the possible solutions. But mind you, that 1 to the power of 3 equals 1. So we can have here to be x to the power of 3 equals 1 to the power of 3. Let's take this one here. X to the power of 3 minus 1 to the power of 3 equals 0. Then let us recall again, when you have a to the power of 3 minus b to the power of 3 always equals as a minus b in parentheses again times a squared plus ab plus b squared. Now coming to this place and applying it here, so we are going to have this as x minus 1 times this x squared plus a x b1, we have here to be x plus 1 squared. Then everything equals 0. Now from here, what we are going to have again will still be x minus 1 times this x squared plus x plus 1 equals 0. Now, by applying zero product rule, we are going to have this guy here as x minus 1 in parentheses to be equal to 0. If this is equal to 0, multiply it here. Here will be 0. Or we have x squared plus x plus 1 to be equal to 0. Now, from here we have x minus 1 equals 0. By taking this one here, we are going to have x to be equals 1. Now, we have x squared plus x plus 1 equals 0. Applying the quadratic formula. So you see that we have, let's define the following parameter. A, the coefficient, to be the coefficient of x squared, 1. B, the coefficient of x, 1. C to be equals 1. Now, applying the general quadratic formula that says our x will now be equals minus b, positive or negative, square root of b square minus 4ac over 2a. Then let us now substitute everything here. So we are going to have x. This will be minus 1, positive or negative. Here will be 1 square, 4 times a, 1 times c, 1 over 2. Now we have this as x minus 1, positive or negative. This should be 1 minus 4 over 2. So we have x minus 1, positive or negative. 1 minus 4 will give us minus 3 over 2. Now, we have x minus 1, positive or negative, root 3 times root of minus 1 over 2. That is the simplification of this. So when you have root of minus a equals as root of a again times root of minus 1, because we can simplify this as root of a times minus 1. And this equals root of a. This minus 1 equals I in a complex number. So we have it to be multiplied by I. So therefore, one can declare that root of minus a equals root a I. So from here, we have x minus 1, positive or negative, root 3i over 2. Root 3i over 2. So, meaning that we have our solution now, x to be 1, to be the real solution, yx equals, let's say we have here to be x1, here to be x2, equals minus 1 plus root 3i over 2. We have x3 minus 1 minus root 3i over 2. So this is called complex solution. Why this also complex solution? Then why we call this real solution? And the reason for the complex solution of this is I. Why this real solution? There's nothing like I. So obviously we can check. Even let us recall. So from here, by inspection, one can decide that x equals 1 because so we have, if x equals 1, we discover that 1 times root 1 is going to give us 1. 1 times root 1 is 1. This equals 1. 1 equals 1.